This is Steve Haggerty from Vanderfield, and this is a VNET tutorial where we're going to look at in-cab software for doing drainage modelling and earthworks designs that you can then connect to your John Deere GPS system. So I guess the first step is to identify, is poor drainage and waterlogging having an effect on your crop yields? Can we quantify it, and is there a significant return on investment? So here we have an example of the slope of a flood furrow irrigated cotton field and the yield, and this is the type of analysis that you would do to quantify if poor drainage is having an effect on your crop and if it's worthwhile spending the money to try and fix. So the software we're looking at today is from PCT, and there's several different options available, but today we're looking at Terracutta Pro. And Terracutta Pro is a in-cab software package that runs on a Windows device where you can effectively collect elevation data and create a design and then connect that design to your bucket in pretty simple steps without leaving the cab. So we start here by collecting some elevation data. So I'm going to load some previously collected points today. Couple of error messages because I haven't got any GPS feed coming in at the moment. And effectively this is what you see in the collect screen. So while you're driving up and down your field with RTK elevation data coming in from your GPS system, you're collecting elevation points. There's some tools here where we can edit out strings of data that we don't need, maybe some errors we made where we went outside the field boundary, and if we're happy with that, we move on to the next step, which is surfacing those elevation points to create a field surface. So now that we have a field surface, we can move on to the next step, which is doing water flow simulations and creating hypothetical designs. So we have the option when we're collecting the elevation data of either operating in the drain mode or the field design mode. So today we're going to look at multi-fit. We do also have the option of traditional best fit designs. So if multi-fit, the parameters are pretty simple. We're simply going to look at the direction of slope, in other words, which way are we farming this field, and what are the minimum and maximum slope parameters that we're willing to accept. So this is actually a dryland field. Being a dryland field, we're going to have some fairly wide slope parameters versus an irrigation field, they're going to be fairly tight. So I've input here a minimum of 0.05% and we'll put in a maximum of 0.4, a target cut to fill ratio, which is going to depend on our soil type that we're dealing with. And we can see that the system has now created a hypothetical new design surface that we may wish to implement. So we can look at water flow simulations in cab. So starting with the original surface, we can see that this field has some fairly significant accumulation points, which are effectively erosion gullies, and that's what we're trying to rectify with this design. And then we can pull up our hypothetical design surface we've just created and see if the parameters have done a job at rectifying those. And we can see obviously that there's going to be a region in the bottom of this field that we may have to treat differently. Then the big question is, how much soil are we going to have to move, and how much is our maximum cuts going to be, and can we afford to implement that hypothetical design? So we simply hit create a cut fill map, and there's our cut fill map. So we have some pretty significant cut areas here of nearly 30 centimetres and around about 230 cubic metres per hectare, which is probably going to be unacceptable. So we can simply play with our parameters here. So we might step the maximum slope in this dryland field to 0.45. Again, put in our target cut to fill ratio. We've created another hypothetical design surface. Again, create a cut fill, and you can see simply by changing that maximum slope, we've now reduced our maximum cut area to around about 10 centimetres, and we've reduced our total amount of dirt to move down to 120 cubic metres per hectare. So all this is done in cab, and the next step, if we're happy with those parameters, is effectively to implement that design by connecting it to your John Deere GPS system. So we keep the surface and we hit apply. So by hitting apply, the Windows device in the cab that's running this software simply connects to the John Deere height controller called iGrade. We get a warning message. Again, a couple of error messages because there's no GPS running at the minute. And here we have the cut fill control map that we see running in our cab. So we have our position, we have our cut and fill depths, and this map is sending commands to the hydraulics on your John Deere tractor, telling the hydraulics to open and shut and maintain the height of our cutting blade according to this design. So hopefully that gives you an idea of how quick and easy it is to use this tool. I guess the advantage for many of our growers out there is that this lets you recycle some of your investment in your existing AutoTrack guidance AMS hardware, and you can put it to use in the off season by fitting it to an earth moving bucket. And it's not limited to just John Deere. We do have options where we can use external control valves to put this onto non-John Deere equipment and even non-agricultural equipment. Thanks for your time.